Hi students, problem number 6. What should be the velocity of the electron so that its momentum equals that of 4000 angstrom unit wavelength photon? So in photoelectric effect, we have studied that photons of a certain wavelength lambda are incident on the metal surface, and some electrons are coming out with the velocity v. So if the initial incident photon's wavelength is 4000 angstrom unit, with how much velocity the electron will come out? So that the condition given is the momentum of the incident photon is equal to the momentum of the emitted electron. That you have to very carefully understand. Okay students, now you see what are the given quantities. Lambda is given, that's all only. Wavelength is given 4 into 10 power minus 7 meter. Now the momentum of the photon, we have studied the de Broglie wavelength, is it not? In terms of de Broglie wavelength, what is the momentum of the photon? That is equal to h by lambda. Okay. Then momentum of the electron is, I have taken P dash is equal to mass into velocity. So these two are equal, that is the hint, is it not? So it is given that m into v for the electron is equal to h by lambda, that is for the photon. So from this we have to find out the velocity of the electron, is it not? Therefore velocity of the electron is equal to h by lambda into m. So we have to substitute h, Planck's constant, and the wavelength 4000 angstrom unit, and the mass of the electron we must remember, is it not? Therefore the velocity of the electron is equal to 6.625 into 10 to the power of minus 34 joule second, that is Planck's constant, divided by lambda is what? 4 into 10 to the power of minus 7, multiplied by mass of the electron is 9.1 into 10 to the power of minus 31 kilogram. So now we have to find out this. So this is equal to 6.625 divided by 4 into 9.1. So what is the product of 4 into 9.1? So that is found to be equal to 36.4. So this is 36.4 into, now you see here in the denominator the power is what? Minus 31 and minus 7. So that makes the 10 power minus 38. So this is coming up to the numerator as what? 10 power plus 38. These two is 10 power 38, and here 10 power minus 34. So that now this ratio we have to find out. 6.625 divided by 36.4, and this is equal to 0.182. So this is a 0.1820 into 10 power 38 minus 34 is 10 power 4. Therefore, the velocity is equal to 1820 meters per second. So this must be the velocity of the emitted photoelectron. Understand? So what we have to find here is the mass, velocity of the electron from the given information. So we have equated the momentum of the incident photon with that momentum of the emitted electron. Okay, I hope you must have understood well. Fine.